Hi everyone, welcome back to Calculating Building Peak Loads in Trane Trace. I am Neil Bulger again, and we are going to pick up with applying templates in Trace and how to use templates in Trace. This is the, where are we? I think this is the fourth element in discussing Trace. And right now I want to take a moment and actually talk about documenting the work we've done and creating a space to document the work going forward in this training. So we've started to put together a peak load input and assumptions spreadsheet so we can start to keep track of one spot for each building to account for all the different assumptions we're making. So to date, or so far in this trainings, we've looked at design days, we've looked at how to find weather files, we've looked at how to make walls and a little bit of geometry, and I thought it might be useful to actually have a building. So to do that, I am going to pick our own office, and I am going to make some crude judgments as I go for training purposes, but we will have something to reference. So I have here saved the architectural set of our office when we renovated it in 2010. Here you can see the lovely rectangular floor plan. Here's 13th Street. Here's Broadway. And down here on the bottom right you can see north is to the top left of this page. So 13th Street is our northeast facing facade. If you've ever come over there in the early mornings, you're quite aware of this. So this will help give us context. So I've gone ahead and saved this PDF set with my trace file, and I've done a number of things. One is I've saved a copy of our peak loads input spreadsheet, which is located currently under the modeling directory, which is buried a little bit. Hopefully we'll find a better spot. But for now, under Oakland Modeling, Templates, and Modeling Input Templates, we have saved this peak load inputs template, and this contains a few tabs. The first one holds general information. What's the building? What's its occupancy type? What's the address? Let's put the address 427 13th Street. This is actually the wrong map, but I can't save it because I'm on the terminal server. But I would recommend putting in the screenshot of the distance to the weather station that we found. Down here you can actually call out the weather station. Right now I'm just using what I can inside of Trace. Ideally I would use Oakland, but Alameda is the only one in Trace right now. So I've copied over what's in Trace for the design day conditions, and I made reference to our architectural set. There are other things we recommend kind of documenting. What are you using this trace model for? The system intent description, so your air conditioning system, if you picked VAV but you're really approximating another system type, maybe include that. And then some other useful ones, and you'll see as we get into other videos, ventilation, the cooling and heating engines we're assuming, and then some of the other basic ones, so walls and other things like that around interior loads. That's the main high-level tab. We have some diversities. We'll talk about diversities at some point. There's another tab, Peak Load Space Types, where we now have a table that is going to document what we're going to talk about today. It's going to document the templates Trace uses, and we'll get into that and then come back here and fill some of these out. So without further ado, let's go back to Trace. And back in here in Trace, I've actually now created one room for our entire office. Probably not the best way to do it for now, but for starters, we have one room. I made our 4 walls, mostly the northeast and the west. I put in 2 little walls that define kind of where the conference rooms face south in the interior courtyard. I made some assumptions on the amount of glass. I even added the very cold interior partition in our conference room. So that is now in there. But templates, okay, so we're going to templates. So click on Create Templates. So a template, as you would imagine, is just a way of applying a space type to a different room or lots of rooms very, very quickly. So often I would recommend making no more than 10 templates, yet no less than 3. Often we'll have offices that include hallways, and then they'll also include storage closets or mechanical rooms or IDF rooms or a backup house space. And inherently, you may need to assign those to some unique space type. I recommend using templates because it's a lot easier to find and review them later in the job than it is to hard code things at each individual room. So let's go ahead and get started, and we're going to rename this one office space type. We're going to hit apply. If you notice, actually, when you first open templates, we're on the internal loads tab, and there's a template tab for internal loads, airflows, thermostats, constructions, and then one that gathers all those 4 into a high-level template. So let's go through them one by one. We'll set up our office space, and then I'll show you how rooms work, and we'll set up a few more space types for internal load. So for here, let's see. You can kind of see what AshRay recommends or what Trace recommends. 140 square foot a person. We're not that dense right now. 250 square foot a person. This is a great way, though, if you do want to start off having Trace pick the amount of sensible and latent loads someone gives off. But for now, let's do that. Workstations, we're not going to really use workstations much. You could if you wanted. Lighting, right now we're at about 0.5 watts a square foot. I'm going to keep it on, let's see, we are, I guess it doesn't, either of these is fine. Fluorescent hung below the ceiling, so that means 100% of the load is going to go into our room. We do not have a plenum, which is a cavity above the ceiling. Miscellaneous loads, this will be our plug loads. Right now we're at about 1 watt a square foot. And I'm going to leave it at that. So there's our internal loads. If we go to airflow, again default, let's call this, we're going to rename it office airflow rate. I'm going to hit apply. And we could turn on AshRay 62.1. And when we do that, we now see we actually change this type, and the people, CFM per person, and area appears. If you had it on no, it stays at cooling and heating. And at that point, you could then pick cooling and pick a different airflow rate. Why don't we pick CFM a square foot? We'll pick 0.15 CFM a square foot, and we'll do the same in heating. We'll ignore the 62.1. Infiltration, here's where we set infiltration. And what else do I want to say? Oh, actually, let's use 62.1 because there is a useful thing that comes into play. So, right, so we'll use 5 CFM per person, 0.06. I'll show you why in a second over here. Infiltration. If we had a positively pressurized building, which we do when we are, well, we don't really cool. I would actually say we do not have a positively pressurized building. So let's assume 1 air change in both scenarios. Also something I'm not talking about, but you can see here schedule. This is for fresh air, and it says we are always moving fresh air, available 100% of the time. I would always recommend leaving it here, not always, but generally just leave it available all the time. Same with infiltration. There's a way to pick a schedule of when does the coincident ventilation ramp up and ramp down. We generally don't tend to go to that level of detail because it can kind of make troubleshooting the model difficult, but you could think about it. So why did I put on 62.1? I wanted to demonstrate that in here, if you are using that, there is an effectiveness question of how effective is our fresh air or even our our fresh air in reaching people. The goal is to get fresh air to the people, and it's harder to do that or easier to do that depending on if we supply cold air low or high, and the same with hot air, low or high. So if we were to supply ceiling air cold, we get 100%. If we were to supply, let's see, which one will change this? If we were to supply fresh air that's cold low, cold air wants to rise, so we actually get 120% effectiveness out of that design. If we were to supply heating above, it will penalize us. There we go, 80%. But if we're supplying it low at the floor, 100%. So let's just keep it at 100% for now. Here is where we would need to account for any room exhaust. If we had a space type that was a bathroom and we want to have exhaust, we could plug that in. We could also put in some VAV controls. Let's not do anything on that since we don't have VAV. And keep going. So thermostats, there we go. Yes, we're going to rename this Office T Stat. Generally, okay, so we have our heating set point, cooling set point, our heating set point, relative humidity. The cooling drift point, you could almost think of that as a nighttime setback, or oftentimes when I'm running a loads model, I want to ensure that whenever the peak occurs, the thermostat is being met. And so to start with, often I will just make this the same as the cooling dry bulb in order to get a number close to, or that is believable. So I know there's less strange things that could be going on because now I've fixed the cooling dry bulb and drift point to always be the same. Alright, moving on, constructions. So constructions is a big one. So let's see, we're going to call this IG, IG Office, IG Construction. And for now, let's see if we can pick some constructions based on the preset ones in Trace. There are ways to make them. It's very not hard. And I will look at that right after this video because I think it relates to templates. Wow, there's not a lot in here to start with. I'm going to pick 2-inch wood floor for a slab because we really don't have a floor that's attached to the mass in our building. Our roof, I didn't actually define a roof, but we might as well pick a construction that is close to what we will have. If anyone has to turn on a roof, we probably have a wood roof. Pick one with insulation. Our walls, framed wall, metal wall, face brick, lightweight concrete. We have a pretty heavy building. Let's just pick one. We don't really face it with brick. That's not exactly right, but that's definitely not right. That's really high. Concrete. But we definitely don't have any insulation in our walls. 4-inch heavyweight blocks. We definitely don't have blocks, but alright, well, let's just go with that because I think that is it's a pretty bad wall. Well, we're not going to find the exact one because I haven't built the constructions from the ground up. So let's start with these. So as we're picking these from the library, over on the right is the overall U value of that assembly. This also includes air films. There is a material layer for the convective and conductive air film layer, which is included in the definitions of each one of these if they were built correctly. So be aware of that. Partitions, we don't have, well, we do have a partition, but it's concrete. There we go. Pretty bad. That's probably close. Our windows are not the best. Oh my, very high. That looks good to start with. Again, we'll look at how you make these exactly if we wanted to know exactly 3 inches of insulation, or if we knew the exact performance value that wall needed to be. It's very important on walls, if you have a minute to think about what it is you're looking to run, that you get a wall type that isn't just the U value it should be, yet it's also a wall type that has around the right mass the building actually has. The model does take into account lag of mass, and that is a key element to making the model work correctly. Now, if it's not in there, your model will do some very strange things, or just be inaccurate and not good for anyone. Alright, so height. I really want to touch on this. We're going to make our walls 12 feet high, floor to floor. We're going to have zero plenum. If you don't click zero plenum, the model will put a plenum in, and it would have put one in that was 2 feet high. Doesn't mean the plenum has exterior walls. just means that 2 feet down over the volume of your space is now a partition, or a plenum. So be cautious of plenum. Okay, so now we've come to the end. We have our room. So this is going to be called our office room type template. And then I'm going to copy it, and we're going to call this conference room type. Apply that. Let's make another copy and call this storage room type. So they still have all the same templates. So we've now sort of created 3 different room templates. We need to go back and make the sub templates for each one of those as well. So again, I'm going to copy this, conference room, interior loads, internal loads. I think there's a conference room. It's pretty dense, slightly different, sensible loads, people not walking around. Lights are the same, and plug loads, I'm going to leave them the same. So we just made it more dense, and then we are going to make storage internal loads. Here we will do no people. We will make the lights less. We will make plug loads less. Apply that out so we have our 3 storage rooms. Let's set up the conference airflow. Conference airflow. Yeah, that's fine. We could actually use this. It's the same. 5.06. That will go up anyways, right? Because we add more people from higher density of square foot per person. We're going to copy that. Storage room. And then I'm going to say no, and we're going to say 0 fresh air for the storage room. So it's important to have a 0 in there. Let's change the thermostat name, because we're actually going to call this like IG thermostat. We're not going to make a different thermostat for any of the rooms because they don't really need one at this point. So now I've made some sub-templates and I need to apply them. So my conference room should be using conference room internal loads, conference room airflow, and then my storage room, I need to go to storage room internal loads, storage room. There we go. So now I have some templates. I have 3 templates. You can also make alternatives. I'm not going to talk about those right now, but assumedly they're all on the same alternative. So, templates in a nutshell. So let's now apply some of these templates. So right now we have this room called the whole IG office. Let's call it IG office area. And we're going to make the office area only 10,000 square feet. And right now it's actually assigned a room, office room type. Fantastic. So that's one room. If I was to make a new room, I will call this IG conference rooms. And let's say we have 1,000 square feet of that. I'm going to change this to conference rooms. Right now, I'm going to assume the conference rooms don't have any exterior walls. All the walls are associated with the office area, just for simplicity. And then we're going to make our IG storage room to make the difference, 2,000 square feet. We're going to change the storage room. So as I change those templates, you can see below the red items are inherited. So if I change the conference room, these 2 changed below. There is a way, if you change something to be not inherited, to restore the ability for that item to be inherited. I'm not familiar with what that is, but someone knows. It's right-clicked or shift right-click. Look it up. It's a shortcut. But anyway, so all the red values are being inherited from those templates. This can come in very handy if you have a model that has lots of rooms. We've had models with up to 200 rooms and 8 different templates. And so there it was key that we apply the right template and we know that every office has a certain set of parameters defined. I'm mostly looking at the single sheets. You could dive into the individual tabs, internal loads, and you would see a lot of the same, we'd see all the same things that were set on those template sheets. Here they're all red because they're all being inherited from the template itself. But it's the same stuff, airflow, internal loads, and I think the thermostat, oh here it is, room. Here's the thermostat information. So, that is applying templates. We'll talk a little bit about constructions and how to look and make